Our last lesson is a combination of both lessons 5 and 6, which is going to be very similar to how lessons 3 and 4 worked. In lesson 3, we had these properties of parallelograms, and then in lesson 4, we said, okay, if we have these conditions, does that mean that we have the parallelogram? And here, we're going to learn about special parallelograms, and then we're going to say, if these things are true, does that mean that our parallelogram is one of these special parallelograms? And so there's a little exploration here. Here, it's follow directions. On this one, it's think and prove, all right? So obviously, again, a little challenging. The goal in lesson 5 is to use properties of rhombuses, rectangles, and squares, to solve for variables and apply it in different ways, etc. But then in lesson 6, we are identifying if the figure that we have is actually a rhombus, is a rectangle, or is a square by using characteristics of the figure, by using characteristics of their diagonals. So those of us that do well with geometric proof are going to do well with this part. And if you're struggling with it, it doesn't mean that you're out of luck. It just means that you're going to have to work extra hard to make sure that lesson 4 and lesson 6 come together well for you. So here's some key vocabulary. If there's any of these terms that you don't know what they are, then we maybe need to have a conversation. Obviously, this is stuff that would be from elementary and middle grades, and so the expectation is that you know what these are. But these are maybe, some of the description here is maybe not how it's written out for you in middle school or elementary school. But basically, here are these figures. You should have these definitions written down. A rectangle has right angles. So that's not a good definition for a square. A square has congruent sides and congruent angles, all right? A rectangle is a parallelogram with right angles, all right, with 4 congruent angles. A rhombus is a parallelogram with congruent sides. And so a square is sort of a combination of a rhombus and a rectangle, right? It has the congruent sides of the rhombus, it has the congruent angles of the rectangle. It is a parallelogram, so it has all of those properties of parallelograms. And so that's why when we're talking about special parallelograms, the facts that we know about parallelograms are true for these figures, that the opposite angles are congruent, that the consecutive angles are supplementary, that the opposite sides are congruent, the opposite sides are parallel, that the diagonals bisect each other, etc. So focusing on that key vocabulary, we then have these ideas. Again, pause the video as needed if I'm going too quickly for your hands to write the information down and to draw all the diagrams. You need the diagrams to sort of make sure that your eyes are visualizing what these phrases are saying. So theorem 6.16, if a parallelogram is a rhombus, so if you've got a rhombus, then the diagonals are perpendicular bisectors of each other. That means that they not only cut each other in half, like is true of all parallelograms, but they are also making right angles with each other. If a parallelogram is a rhombus, so again, given a rhombus, then the diagonal bisects the opposite angles, which means that these are congruent and those are congruent, which means that these are congruent and those are congruent. Now here's what's weird. How I've drawn that is important to see how I did that. So these are all 4 marked the same, which means that this angle, this angle, this angle, this angle are all congruent. These are marked the same, which means that this angle, this angle, this angle, this angle are all congruent to each other. Think about that. Alternate interior angles are congruent, alternate interior angles are congruent, but these big angles were bisected. And so that means that they are congruent to each other, they're congruent to each other, but these are congruent and those are congruent. So that means all 4 are congruent. That's how we explore it. All right? So this is about rhombuses, and which means that we can use this information to solve problems about special parallelograms. So here we're going to solve some situations around rhombuses. In this case, it says, given this situation, find the value of x. Well, in this case, we need to know a couple things. Since this is a rhombus, it's marked accordingly that all of the sides are congruent. We know that it's a parallelogram. Great, grand, wonderful. If the opposite sides in a quadrilateral are congruent, then it is a parallelogram. So it's a parallelogram with congruent sides. Okay, it's a rhombus by definition. Here we go. We know that this is 53, and we know that this is 53. We know that this is 53. We know that this is 53. All of those are 53 degrees, all right, because the angles bisect each other, right? The diagonals bisect the angles. We know that this is x, we know that this is x. And we also know that the diagonals are perpendicular to each other. So we know that all of these angles are 90. So we basically have this situation where we have the acute angles in a right triangle are complementary. So 53 plus x equals 90. If you don't like this equation and you want to do 90 plus 53 plus x is equal to 180, that's fine. You can do that. Subtract off 90 from both sides, and now you have this situation. Now we just need to subtract 53 to find that x is equal to 37. You don't need to label all these things when you are doing this work, but if you're not labeling all those things and you don't know what to do, you probably need to label all the things. all right? So that's my exhortation to you is if you can do this without writing that all these are 53 and all of these are x and these are all 90, then great, that's awesome, do that. But if you're like, I don't know how to, I'm stuck on this, I'm stuck, I don't know how to do that, well then label it, mark your diagram. Because if you're not marking your diagram, then you're not setting yourself up for success. Here, I want for you to do. Here, this is not to do with angles. These are segments. This length is 2x plus 3. This length is 4x minus 7. This length is 3x plus 1. It wants for us to first solve for x. And then once we know what x is, use that to find the length of segment GH. This one's a little more involved and is going to require some thinking. Draw the picture, do the algebra, right? Write your equations, write your relationships, and go from there. All right, theorem 618. Still, we're dealing with parallelograms, special parallelograms here. If you have a rectangle, a parallelogram with 4 right angles, then the diagonals in that rectangle are congruent to each other. That has not been the case yet with our parallelograms. It's not the case with rhombuses, unless our rhombus is a rectangle, and we'll talk about that situation in a minute. But if we have a rectangle, then the diagonals are congruent. The proof on this is not too bad. The proof on this, you are going to show that a pair of these overlapping triangles are congruent by side, angle, side, and then you're going to prove that the hypotenuses are congruent by CP/CTC. So here is your proof. You're given a rectangle, which means that you know that the opposite sides are congruent. You know that you've got right angles. You know that you have these angles congruent. These right angles are congruent. You've got this reflexive side, and therefore the triangles are congruent. Once you have the triangles congruent, you can say that the corresponding parts are congruent. So I've kind of explained all the reasons. Your job is to fill out those reasons, all right? So I just gave you basically all the answers on that. If you listen back through that, then I've given you all the answers. All right, but since that's true, we want to be able to apply that with rectangles. And so I might have a case where we say, hey, this is a rectangle. You need to know, oh, those opposite sides are congruent, all those angles are right angles, those diagonals are congruent to each other. All right. If the diagonals, and this is the converses now. Now we're starting to think about the 6-6 work. If we have these situations in a parallelogram, that means that our parallelogram is a rhombus or a rectangle or whatever. So let's think through this. If you have a parallelogram and the diagonals are perpendicular, then that parallelogram has to be a rhombus. It must be a rhombus. It cannot be a general parallelogram. It is a special parallelogram if these diagonals are perpendicular. All right? In theorem 620, the converse of theorem 617, if the diagonal bisects the opposite angles, then that figure, that parallelogram, has to be a rhombus. It must be a rhombus. The proof on this is a little bit easy. Here we're going to say that these triangles are congruent by ASA, right? Pair of angles, pair of sides, pair of angles, or pair of angles, pair of sides, pair of angles, right? Because these are interchangeable. But also, we know by the isosceles triangle theorem that these sides opposite the angles are congruent to each other. So just because we have an isosceles triangle and an isosceles triangle doesn't mean that those are congruent, right? This could be a kite. But we do know that we have shins of fun. We do know that we have I pressed the button. We have CP/CTC, and so we know that these sides are congruent, and we know that these sides are congruent. Or since it's a parallelogram, we know the opposite sides are congruent. So we're kind of doing a combination of the isosceles triangle theorem, or the converse of the isosceles triangle theorem, that the sides are congruent, but also using the theorem 6-7 that says that the opposite sides in a parallelogram, because we have a parallelogram, that those sides are congruent to each other. All right? And so thinking through those, given these particular cases within parallelograms, that parallelogram is a special parallelogram called a rhombus. The converse of 618, if the diagonals are congruent, then this parallelogram must be a rectangle. And then, of course, we want to talk about squares. All right. Now, when we are talking about squares, this is just fact. These aren't theorems. This is just thinking. All right, and applying what we know about our figures. All right. So a parallelogram is a square if, first of all, if it's a rhombus and a rectangle. Think about it. If a parallelogram is a rhombus and it's a rectangle, if it has both those characteristics, it has to be a square. The sides are congruent, the angles are congruent. It is a regular quadrilateral. So here, a parallelogram is a square if the diagonals are both perpendicular and congruent. If the diagonals are perpendicular, then that means that it's a rhombus. If they're congruent, that means that it's a rectangle. So if these two things are happening, then it is a rhombus and a rectangle, which means it's a square. A parallelogram is a square if the diagonal bisects the angles and the diagonals are congruent. So if the diagonals are congruent, rectangle, and if it bisects the angles, rhombus, then that means that it's a square. All right? Maybe hard for us to grasp, but hopefully we can tell kind of by visualizing it, but then also by thinking about it, that we are dealing with a square. So folks, a ton of information here, right? And a lot of geometric proof. We have to understand how to prove triangles congruent, how to apply congruent triangles, along with the definition of congruent triangles, or CP/CTC, to show that we have these special cases. All right, now we're going to use that information to do some thinking. Again, the thinking questions are the hard questions in our work. Can we conclude whether each of these parallelograms is a rhombus, a rectangle, or a square? So we're saying that these are parallelograms, so the opposite sides are parallel. That's huge. The second thing is you're given some other information. And so let's see what you can deduce. You're going to think through these, and then we are going to discuss in class. You do. So it's going to be in your notes when you upload them. But we will discuss in class. I mean, we discuss the other stuff too. But this is going to be a formal discussion explaining whether these are or are not special parallelograms. All right? And that's going to be an important conversation, so don't miss class for that. If you do miss class and you want an explanation on your answers being right or wrong, then we will have that conversation in person. You'll come see me after school or during seminar if you missed class. All right, that is the end of our lesson. That is the end of our chapter. A lot of information on this one. This is kind of a doozy, but hopefully we can think through all of that awesomeness. I know it's a short video, but a lot of explanation. Rewatch as needed.